Imagine a camera so powerful it could capture the entire night sky every few nights, over and over, for a decade. Imagine a machine that uncovers millions of hidden worlds and rewrites everything we thought we knew about our solar system, our galaxy, even the very forces shaping the cosmos. This isn't science fiction. It's happening now, on a remote Chilean mountaintop. Welcome to the dawn of the Rubin Revolution. In 2025, the Vera C Rubin Observatory will switch on, and the universe will never look the same. But what exactly is this billion-dollar observatory, and why are scientists calling it a paradigm shift? A once-in-a-generation leap that promises to unlock cosmic secrets and might even help save our planet. Let's rewind. For centuries, humanity's quest to understand the universe relied on slow, painstaking observations, astronomers gazing through telescopes, sketching faint smudges of light. In the 20th century, photographic sky surveys, like the Palomar Observatory Sky Survey, started to map the heavens systematically. By the early 2000s, the Sloan Digital Sky Survey used digital technology to catalog hundreds of millions of celestial objects, opening the floodgates to what some called the era of big data astronomy. But the Rubin Observatory, formerly the Large Synoptic Survey Telescope or LSST, goes far beyond anything that's come before. Funded by the U.S. National Science Foundation and Department of Energy, this project has been decades in the making. The telescope itself boasts an 8.4-meter mirror, one of the largest ever built, paired with the world's biggest digital camera, a staggering 3.2 gigapixels. Every few nights, Rubin will scan the entire visible sky, using 6 color filters, including a crucial ultraviolet band that lets scientists distinguish ancient stellar streams and faint galaxies. The numbers are mind-blowing. Rubin is expected to generate 15 petabytes of data catalogs over its 10-year survey. That's more information than all of Facebook's images, combined. Each night, algorithms will sift through terabytes of fresh data, flagging about 10 million objects that change in brightness or location, potentially everything from exploding stars to rogue asteroids. It's not just the scale that's revolutionary, but the precision. As Adam Miller from Northwestern University puts it, the transformative aspect of what Rubin will be doing is not just the scale, but also the precision. This is going to allow for a lot of science that before now has been very difficult to accomplish. Why does this matter for our everyday lives? For starters, Rubin will exponentially increase our ability to spot potentially hazardous asteroids, objects that could threaten Earth. It will also map the mysterious dark matter sculpting our galaxy and probe dark energy, the force driving the universe's accelerating expansion. With Rubin Observatory, we'll be able to use stellar streams to figure out how dark matter is distributed in our galaxy, from the largest scales down to very small scales, says Nora Shipp of Carnegie Mellon. And yet this unprecedented flood of data creates its own crisis. How do you process 15 petabytes of information, every detail of the dynamic universe, without drowning in noise? Who gets to decide which cosmic mysteries get priority, and which algorithms are best at separating the profound from the trivial? Mario Jurich of the University of Washington warns, when the observatory starts in 2025, it'll be a gold rush to figure out what's the best algorithm to find the most interesting objects. As the clock ticks down to first light, a global race is on. Teams of scientists, software engineers, even amateur astronomers are vying to build the smartest tools to mine this cosmic goldmine. But with so much at stake, planetary defense, fundamental physics, our place in the cosmos, what happens if we miss something crucial? Could our rush for discovery blind us to the very threats or opportunities we most need to see? The answer, and the future of cosmic exploration, may hinge on how we handle the data deluge about to crash down on us. Now let's imagine the world just a few years from now, as the Vera C Rubin Observatory begins its nightly scan of the heavens. Every 24 hours, it will flag around 10 million objects that have changed. Asteroids, comets, exploding stars, mysterious flashes. That's an avalanche of alerts, more than any human team could hope to sift through. As Mario Jurich from the University of Washington put it, when it starts in 2025, it'll be a gold rush to figure out what's the best algorithm to find the most interesting objects. If our algorithms miss something, say a faint but fast-moving asteroid on a collision course, what's at stake? Or what if a subtle flicker in the data hints at new physics, but gets lost in the digital torrent? The risk is real. For every discovery we make, there's a chance something vital slips through the cracks. Yet this challenge is also an extraordinary opportunity. The observatory could help us spot threats to Earth sooner, or unlock secrets about dark matter and energy that have eluded astronomers for generations. As Nora Ship of Carnegie Mellon notes, Rubin will let us figure out how dark matter is distributed in our galaxy from the largest scales down to very small scales. So what does this mean for you, watching right now? First, it's a reminder that our future will be shaped not just by the data we collect, but by the tools and minds we use to understand it. The need for citizen scientists, for creative coders, and for educators has never been greater. You don't have to be a professional astronomer to play a part. Open data from Rubin means anyone can join the search for new worlds, or even help protect our own. But there's an even bigger lesson. The Rubin Observatory is a mirror for our information age. More data alone isn't enough. We must learn to ask better questions, build smarter systems, and stay vigilant for the unexpected. The stakes are cosmic, but so is the potential for discovery. So, are we ready for this data gold rush? The answer is, only if we're humble enough to admit what we might overlook, and bold enough to chase the unknown. By embracing both human curiosity and machine intelligence, we can turn this tidal wave of information into a new era of exploration. If you're excited to be part of this future, hit subscribe, share your thoughts below, and stay curious.